Hi, I'm Seongsik, presenter of this study that study on changes in the dissolved oxygen concentration due to the pandemic. The COVID-19 spread around the world and changed not only our lifestyle but also coastal environment. First, chlorophyll concentration. The chlorophyll concentration in the global coastal sea increased due to increase of residential wastewater load from land side. And second, the increase of chlorophyll concentration implies a phytoplankton bloom, and the phytoplankton bloom makes DO concentration to increase by photosynthesis. And several studies have reported that on increase of chlorophyll concentration accompanies increase of DO concentration too. However, in long-term point of view, the massively accumulated organic matter such as residential organic matter and dead phytoplankton, it consumes the DO concentration in the bottom layer and makes it to decrease. So, and to the best of our knowledge, there are no studies that changes in chlorophyll concentration after COVID-19 for coastal sea of Korea. Especially, there are no studies on changes in DO concentration for the world. First, we did the investigation, the POC, the particulate organic carbon, and chlorophyll concentration in the coastal sea of Korea using satellite data, and to predict the DO concentration using satellite data and machine learning tool under this hypothesis. After the spread of COVID-19 in the South Korea, based on January 2020, because the first infected person occurred in South Korea in January 2020. The organic matter concentration along the coast increased due to increase in the amount of organic matter load from the land side. It means the increase of particulate organic carbon concentration. And second, the phytoplankton bloom, it means the increase of chlorophyll concentration, and it makes the DO concentration to increase by processes in the short term. But in the long-term point of view, the DO concentration decreased by massively accumulated organic matter consuming the dissolved oxygen in the bottom layer. And this is the satellite data. I get the satellite data from the Communication Ocean and Meteorological Satellite in Korea, the POC and chlorophyll concentration. The satellite observes the coastal area of South Korea every 1 hour from 9 a.m. to 4 p.m. with 500 meters of spatial resolution. So we check the POC and chlorophyll concentration every August and September from 2012 to 2020, and we mostly average the 1 hour interval data. And this is the DO prediction process in coastal sea. We use the satellite data only to predict the surface DO concentration, such as the sea surface temperature from the aquamodis satellite and ocean color data from the COMS satellite, such as remote sensing reflectance, chlorophyll, and diffuse attenuation coefficient, and pH concentration. The response variable is DO concentration, observed by Body Environment Monitoring System in Korea. And then we did mapping and gathering of satellite data to DO data. The total station of DO was 425 stations located in the coastal sea of South Korea, such as this right map. And we checked the data from we used the data from 2012 to 2020. The total data point was 3096, and we used 85% of the data for training the model, and the rest 15% data for validation. And we used the Gaussian process regulation model based on machine learning. It's kernel-based model, and so it means the non-parametric model. Usually, non-parametric model shows high flexible for training data, and it has high accuracy. So usually the parametric model shows higher performance than non-parametric model. And this is the flow chart of DO prediction, surface, and bottom DO. First, the surface DO prediction using satellite data only as a predictor for running the GPR model, and we consider two cases of predictor set to predict the bottom DO concentration. Case 1 is satellite data only, and case 2 is satellite data and predicted surface DO, such as this flowchart graph. And next is the visual of POC concentration in August. After COVID-19, specifically August 2012, 2020, the POC concentration in the southern coast of South Korea, namely SC, was relatively higher than the average from August 2012 to 2019. Specifically, the POC concentration in SC1 was relatively high. The concentration in August 2012 was 624.5 microgram per liter and is 96% higher than that in August from 2012 to 2019. And the increase of POC concentration occurred in the western coast of South Korea, namely WC, also in September 2012. The POC concentration in averaged in WC area in September 2012 was 780.2 microgram per liter and is 34.6% higher than that averaged in September from 2012 to 2019. And next is corporate concentration in August. After COVID-19, the corporate concentration in the southern coast of South Korea was relatively higher than that averaged from August 2012 to 2019. And the corporate concentration averaged in SC1 was in August 2012 was 14.3 microgram per liter, and it was 276.5% higher than that averaged in August 2012 to 2019. And next is corporate concentration in September. The increase of corporate concentration occurred in the WC area also in September. The corporate concentration averaged in WC in September 2012 was 8.2 microgram per liter and is 60% higher than that averaged in September 2012 to 2019. And in SC, in the southern part, in September 2012, the corporate concentration in SC1 was 6.3 microgram per liter, which was 55% lower than that in August 2012. It means that the massively proliferated phytoplankton was died and sank to the bottom. Next is what caused the phytoplankton bloom after COVID-19. I think the COVID-19 caused the phytoplankton bloom because the COVID-19 changed our lifestyle, changed to homestay. In a survey in Korea, 93.6% of Korean respondents said their stay time at home increased. And the lifestyle change followed by increase of wastewater. In 2012, the wastewater increased by radiation of wastewater increased by 5% and discharge of wastewater increased by 3.6%, and the sewage treatment load in the southern part of Korea increased by 9%. And meanwhile, the quaternary ammonium surfactant, namely QAS, which is used to disinfect the COVID-19 virus. The QAS cross into the host and act as toxic to marine life, which is paired to reduce marine life population. It means several species in the coast act as a same organic matter. It means that the QAS can cause increase in organic matter in the coastal area. And then next is the prediction in DO concentration region. First, the validation measure. So in surface DO prediction, the I scale was 0.64 and the RMSE error was 0.61. And in bottom DO prediction result, in case 1, which is to use satellite data only as a predictor, the I scale was 0.69 and RMSE was 0.75. And in case 2, the R scale value increased about 0.07 and the RMSE decreased about 0.1. It means in case 2, it shows higher performance to predict the bottom due prediction. In the changes in DO concentration after COVID-19 in August, in surface DO prediction, the mean surface DO prediction average in SCC1 was 8.3 milligram per liter, which was 0.5 milligram per liter higher than that in August 2019. It was due to the photosynthesis by phytoplankton massively proliferated after COVID-19. And in bottom layer, the bottom DO concentration near land side was higher than that in August 2019. It was due to diffusion of surface DO into the bottom. In September, after the phytoplankton bloom, after they was died, the bottom DO concentration average in SC1 was 6.9 milligram per liter, which was 0.2 milligram per liter lower than that in September 2019. And the two data group between 2019 and 2012 shows significant difference. And in September 2012, in a histogram graph, in September 2012, count of cells higher than 7 milligram per liter in SCC1 was 3,588, which was less than half of that in September 2019. And the count of cells lower than 7 milligram per liter in SCC1 was 9,130, which was 75.3% higher than that in September 2019. It means that after COVID-19, the relatively low bottom DO concentration in SCC1 compared to September 2019 was due to higher DO consumption rate by massively deposited organic matters, such as heterogeneous organic matter and dead phytoplankton. In summary, after COVID-19 in the coastal sea of Korea, the POC and Korea concentration in the southern coast of South Korea increased about 87% and 296% compared to the average from 2012 to 2019. Also, these results were occurred in the western coast of South Korea in September 2012. It is presumed that there was phytoplankton bloom due to the loss of organic matter. And the DO concentration in the southern coast was predicted to be higher than that in August 2019. It was due to the photosynthesis by phytoplankton massively proliferated after COVID-19. However, in September 2012, after the phytoplankton was died, the DO concentration was predicted to be lower than that in September 2019. It is presumed that the loss of organic matters accelerated DO consumption.